Hey, this is JT with RMUS. I'm here in Ho Chi Minh City, Vietnam, Saigon, with Quoc at the factory. And so what I wanted to show is really what it takes to make a drone. That is not easy. All the different components that go into the testing, the sourcing, finding the right components that are actually going to work for everything. So I can explain it all to you, but it's much easier to see it. So what we're going to do is kind of give you a quick tour of what we've been working on for 3 years now. The solution here is very intricate, but also Quoc is making it very, very simple. So when you take the drone off, you fly, you see the image from the camera, all that, there's a lot behind the scenes that's happening. So let's take a look. What we really like too is the integration, how everything is all made in-house here. Very, very hard to integrate all different types of components into this. So what we're looking at right now is where it all starts. This is the design phase, where right now they're working on the remote control, doing some design there. As you can see, a lot of collaboration on the team as they do this. Some of the groups down here are working on the camera system as well as the mounts. We wanted to show you this. This is really cool because this is a new product that Quoc is working on. It is the Sony ILX camera with a FLIR boson sensor, laser rangefinder. And you can look in a little bit here. Look at the design of this. Now, Quoc, how long have you been working on this? I think over a year, correct?
Over a year.
Over a year. So right now they're refining this, and look at the whole gimbal system that they're working on to set that up. Not easy to have something this complicated. Now, we've talked about this before. Can you flip it? Maybe let us see the back of it, if you don't mind. This is what's very unique. This is what makes this payload completely different from anything else on the market. You have a SSD card on the back there that allows you to pop the data out very quickly, put it onto your computer. But basically there's a piece that goes on the back of the body of the camera that is a computer system. Quoc, maybe explain a little bit about what that computer is doing.
What that computer is doing is this. So it can do live geotagging of the video, RGB video.
So we have live geotagging?
Live geotagging of the thermal video.
Live geotagging the thermal video.
And it also can give the exact coordinates of the target, not just the camera. And it saves everything onto the SSD card at the back.
Okay, so
show the SSD card. So after you fly, after you finish your mission and you land, you take out the SSD card and you have everything in there ready for processing. Yeah.
And the computer system on this and the heat sinking, it's allowing the camera to take full video. There's been the bare bones version of this doesn't take video for very long. This allows you to take continuous video. And one other nice thing, like we mentioned earlier, is with the laser rangefinder, we're able to look in the distance and see really what the geolocation is of a point as we're looking at that point in the distance.
So from the design to the prototype, this takes a lot of time.
Yeah.
And then we put the camera on, and then we do a lot of tests on the bench.
Yeah, so a lot of bench testing. The design starts with something like this. Now this I can see is just kind of very basic, this is aluminum.
Yes.
So this doesn't really have any sort of components. This is really just getting the balancing and weighting happening to then add the payloads and the electronics to that. So really interesting, what it takes, So when you're getting that finished product, there's a lot of, as you can see, lots and lots of engineering and time to get that perfected. So it just makes it very simple to use.
So this is the computer that we put inside.
Okay, so what we're looking at here is the actual back of the camera. I'm not gonna, sorry.
Take it.
I didn't mean to touch your workspace here, but it's a lot easier sometimes when we show the back. Now, this is, Quoc, help me out here. This is the board that you built.
Yes.
And this is going on the back of the camera, correct? So the back of the camera pretty much ends right here, correct? Yeah. So this has all been designed by the RTR team, and he's actually putting the finishing touches on the finalization of what that looks like, so it's nice and clean.
That's a computer.
There you go.
Let's see.
All right, here we are at the carbon fiber molding area. Let's take a look a little closer here. Come on in. So what we have is the mold itself, and then they're overlaying the carbon. This is an actual propeller being built here. We have the body over here. So Kwok, help us out here and explain what we have, what we're looking at here.
So first of all, we use a CNC machine to cut the carbon fiber fabric into shapes, and then we use the mold. We design our own mold, and then we put the carbon fiber layers after layers into the mold, and then we put the whole thing into an oven and to cure them. And
so what we're getting here is there's a machine in the back here, the little proprietary. We're not going to show you that, but the carbon fiber gets cut and placed into the molds. Now, Kwok, once again, this is about 2 years in the making to get this this process perfected correctly. Okay.
Yes.
So once they're overlaid into the molds, just as they need to be, the molds are then put together. There's some air, if it's depending on what you're doing. Obviously, the propellers don't have air in between them, but these bodies do. And then those get put into the oven. So this is what the finished product looks like as it comes out. We also have a propeller right here. But pretty amazing what's happening here. So what I have are the carbon fiber sheets here. So as you see, the machine is actually getting these propellers ready. And then they're placed into the mold here, right? And as they do their thing with the mold, and then the mold comes together and then gets placed in the oven. And then what you have is the finished product here of the propeller. Once again, on the body, it's slightly different. The body actually has to be very carefully made with air that's injected into here to give you that hollow body to run your electronics through. So that is the manufacturing process for the carbon fiber. Okay, here we are in the battery area. Finished product behind me here. In front of me here are lithium-ion cells for the batteries, and it's kind of interesting to see what the battery looks like on the inside, right? So with large drones, over time we've had large battery packs that are hard to manage, hard to take care of. That's not the case with the HERA. The team here has made it very easy. Kwok, explain to me a little bit about what goes into the smart battery.
so number one is that we use the lithium-ion cells from Samsung, and this lithium-ion cells has one of the top energy density, and it can also give a very high discharge current, and that's what a heavy lifter would need it.
So
Right.
high discharge current,
Yeah.
heavy or large capacity batteries,
Yes.
lithium ion. And now we've got, here is the board that makes it all happen, right?
Yes, this is called a BMS, and we designed this BMS in-house, and we developed the algorithm, battery management algorithm.
So the
in-house.
BMS, battery management system. And so with the HERA, you've designed your own battery management system
Yes.
for this. So
Why we need to design our own batteries? Because we want to optimize the shape, the weight, the control algorithm, and also the energy density. And that's why HERA can fly for 1 hour with this battery.
yes, yes. Now that's another video we made, but yes, I verified. We headed up for, we did 19 kilometers, or 20 kilometers out and back. And we still had 30 minutes of flight time, and we had 50% battery. So, Kwok likes to say this, a lot of the spec sheets are actually tested, and we sandbag it a little bit, and they're actually flying a little bit longer, but we want to make sure that the customers are getting the specs that we've put on those sheets. So here we are with the payload development team. So there's a lot that goes into having this, the payloads that are going onto the HERA, right? So we have the mounting system here. We also have the gimbal system. It is not easy just to get the gimbal balance for some of the payloads. So as you know, the HERA can carry up to 3 payloads. And on those payloads, you might have 2, maybe 3 data feeds coming through that. So a lot of data that's coming through. And all that is managed by this team here coming into the Regis software. So the Regis software is what you're interacting with as you're flying the drone from the flight control system, as well as the payload management system. So we're able to do these payloads like the HERA sites, as well as the drop system, the speaker spotlight, the Ophiel payloads, and there's others that we're working on down the road. So Kwok, help me out here. Tell us a little bit about what the process is as you start to do, as you're programming this, putting it all together.
Okay, so because HERA can mount multiple payloads simultaneously, so we need a software that can display data from multiple payloads and that can control multiple payloads, right? And there is no such a thing, such a software available on the market. That's why we have to develop our software from the ground up. And if you look at the screen right here, right, we develop AI feature, right? Turn on the AI feature. That can so the AI can tell right away, this is a cell phone, this is a person, right? This is a bottle, right? All of those features and full access to the cameras, all of those features and capabilities we develop here.
So once again, I mean, the HERA is a highly sophisticated drone with a lot of different payloads, and you may see the mapping software is using some sort of a Q ground control, but all the other features that you're seeing are all built in-house here by the RTR team into the Regis software.
Yeah. Another example is that this software can give the user full access and full control, not only HERA side, but also the Ophiel camera.
Yeah, great. That's a great point. So, it's taken us some time to develop the Ophiel payload. The Ophiel payload is looking for ultraviolet light coming off high voltage transmission and distribution lines. And we were able to take that camera and really integrate it fully with the HERA. So it's just touch and tap and you're getting the data and everything you need right at your fingertips. So it's just plug and play. All right. This is where the brains of the operation are. This is where all the boards are designed. So not only are the boards designed here, but all the firmware that goes onto that for the avionics that make the drone, well, both fly and navigate. The flight control systems are all developed in-house here. So what we're looking at is just the design here of what it takes to actually design that board. And then if we move over this way, this is where all the electronic components are stored. And then as that gets developed, we're then creating the boards here that they can go out and then be prototyped and tested. And once they're tested and working, then they're produced. And you can see here one of the boards, right? So this is the intricacies of all the inner workings of the drone. So once again, this team here is actually working on the functionality of all the parts and pieces of the HERA itself.
This is where firmware development takes place in real time. Yeah. He's developing the control algorithm for gimbal, and this is the prototype gimbal that we are testing, running the new algorithm until we can perfect them.
Yeah, amazing. So we have the team downstairs working on the functionality of the user interface, and the team here is actually working kind of on the involuntary side of things, making all this function with the firmware on it. Something that they've worked on, changing the cube here. So the flight control system, new cube comes out with some enhancements. So in order to change that, it's not just a matter of sticking a new cube in here, it's a matter of then, take a look at this, going out into the field, getting all the diagnostics, getting the, what do you call this, all the numbers and data?
Yeah, all the data, all the, like...
we have to fly hundreds of missions, and then we have to compare the...
just like compare the parameters, all the, like the message, all the data that all collected during the flight. Yeah.
Actually, we have to compare the performances of all of the major sensors on the crew.
Yeah, and then we have to do coding for the analysis.
Yeah. All right, so the intricacies of all the parts and pieces that go into that. A lot of that is stored in this room here. This is where I'm looking at all kinds of little screws and parts and pieces and all that, right? You name it, everything's in here. So just remember what goes into sourcing all the parts and pieces for a drone. I mean, even these little connector pieces here, all this has to be in stock, ready to order. And then there's also the QA that goes into this of the checklists that have to be done for each different component and the parts and pieces. These are basically bill of materials for all the parts and pieces that go into this. And as you can see, there's a checklist, and then it's signed off on when all those are completed.